We will start with Unit 2, which is gravitation. And in this unit, we have two lessons. We have Lesson 4, planetary motion and gravitation, and Lesson 5, using the law of universal gravitation. In this lesson, we have 6 questions. 5 of them are multiple choice questions and 1 solving question. But this question probably has 10 marks, so we have 10 here, and 5 times 4, that's 20, so in total 30 marks. Question 4 says, explain Kepler's first law, which states that planets follow elliptical paths with the sun at one focus. Kepler's first law states that the path of the planets are ellipses with the sun at one foci, or at one focus, and the planets move faster when they are closer to the sun and slower when they are further away from the sun. So here you can see that the shape of the planet's orbit is an ellipse, and the sun is placed at one of the focus points of this ellipse or elliptical shape. And you can see that the speed of the planet increases when it's closer to the sun and decreases when the planet is further away from the sun. And this is the image given to you in the book. Which of the following physics laws describe the planet's orbits as represented by the figure below? You can see that the orbit is ellipse or elliptical, and hence this is Kepler's first law. The Earth moving in an elliptical orbit, well, it moves faster when it's closer to the sun. Similarly here, at point 1, Mars would be fastest. Mars would be fastest at point 1 because it is closest to the sun. So because it's closest to the sun, it will have highest speed or highest velocity. Kepler's second law states that, or for objective 1 here, it says explain Kepler's second law, which states that an imaginary line from the sun to the planet sweeps out equal areas in equal time intervals. So let's say that this planet takes 10 days to go from point 7 to point 8. It also takes 10 days to go from point 8 to point 9. If we draw a line that goes from the planet to the sun, this area that the planet has swept is equal to this area right here. So it crosses or sweeps out equal areas at equal time intervals. This is called Kepler's second law. Which of the following describes Kepler's second law? Well, it's also known as the law of equal areas. Kepler's third law, which is this solving question. Now, this question is most likely to be a match question, Allahu Alam. This solving question mentions 4 different topics, which the first one, explain Kepler's first law, which states that the planets follow elliptical paths with the sun at one focus. Explain Kepler's second law that we've just stated. Explain Kepler's third law that we will do in a minute, and explain the law of universal gravitation, which we also will explain in this point. So because it has so many points and no questions were mentioned, this question most likely to be a match question. Match the law with its statement. All right, let's explain 3 and 4 here. 1 and 2 we already have explained in the previous 2 objectives. Objective 3 says that we need to explain Kepler's third law, which states that the square ratio of the periods of any 2 planets revolving around the sun is equal to the cube of the ratio of their average distance from the sun, and this is the form of the equation. So T here represents the period of the planet. It's how much time it takes the planet to make one cycle around the sun. And TA is the period of planet A, and TB is the period of planet B. The period can be measured in seconds, years, days. You don't need to convert any of them because most likely both of them will have the same unit, and because they're divided on one another, the units cancel. R is called the orbital radius. It's the distance between the center of the sun and the center of the planet. And you can see that it is the radius of the orbit that the planet follows around the sun. Right. And it's measured in meters, kilometers, units, and so on. We have this question as we solved in the lesson. Neptune is nearly 10 to the power of 13 meters from the sun. So because this is in meters, that means that this is the orbital radius. This is the orbital radius of Neptune from the sun. So this is our Neptune. We can call it our Neptune or Rn. And Saturn is nearly at 10 to the power of 12 meters from the sun. So this is our Saturn. This is the orbital radius of Saturn. Which of the following is correct? Is the correct ratio of their periods? Now remember, TA over TB. Well, since here we have Neptune and Saturn, we can call A and B, or A is for Neptune and B is for Saturn. So T Neptune over T Saturn squared is equal to R Neptune over R Saturn cubed. Now he wants me to find He wants me to find the ratio of their periods. So this is the unknown. T Neptune over T Saturn, and you can figure it out from the options. So in the calculator, the whole thing is the unknown. Okay, so T Neptune over T Saturn is the unknown, so I'm going to replace it with X. R Neptune, as given in the question, is 10 to the power of 3, and R Saturn is 10 to the power, 13. R Saturn is 10 to the power of 12. Don't forget the cubed. The calculator, okay. How can I move the calculator now? So I can't move the calculator, but we already know the equation. It is x squared is equal to a bracket fraction, and we have 10 to the power of 13 on top and 10 to the power of 12 on the bottom, and close bracket, and then raise to the power of 3. You can reverse the video a little bit so that you can make sure of the equation. Then we're going to hit Shift, Calc, and Equal. Now, there you go. So the answer is 31.6. So the ratio of their periods is 31.6. 31.6. So the answer, the ratio of their periods, T Neptune over T Saturn, that we want to find is equal to 31.6. You can see that the options are, none of them is 31.6. But you can do these two operations in order to find if one of them is the true answer. The square root of 1000 is equal to 31.6. So this is the correct answer right here. Which of one of the following states Kepler's third law? Obviously this one right here. We have, of course, the last one, number 4, says explain the law of universal gravitation and write the equation in the form of Fg equals to gm1 m2 over r squared. This is the law of gravitation. This is the universal law of gravitation. The universal law of gravitation states that any two masses have attraction forces between them, and this force is proportional to their masses and inversely proportional to the square of the distance between them. So this is the equation that is used to find the gravitational force. The gravitational force measured in Newton equals to G, where G is a constant. It's 6.67 times 10 to the power of negative 11 Newton meter squared over kilogram squared. This is the unit of the G. M1 and M2 are the masses in kilogram, and R is the distance between the two objects in meter. This is how the question can come in the exam, since there's no mentioned questions. Match the law with a statement. Kepler's first law states that the path of the planets are ellipses. Kepler's second states that an imaginary line sweeps equal areas. Kepler's third law states that the square of the ratio of the periods equals to the cubed of the ratio of their distances. And the last link, the universal law of gravitation, states that the object or objects attract other objects with force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. All right.